With Lorentz, you don't have this effect. Only to give you an idea of other possibilities, what will happen when we spin the spherical shell? Now we have the same situation. We have a test particle moving and being accelerated by a spring, by a magnet, by my hand, inside the spherical shell. But now the spherical shell is uniformly charged and spinning. Okay? When you integrate, in this case, with Weber's law, what do we get? We get three terms if it rotates at a constant angular velocity. It will be the usual one, which I presented earlier, and two extra terms, which depends on the rotation of the shell. If you calculate the same expression with Lorentz, if you have still a uniform charge distribution, there will be no electric field. But in this case, there will be a magnetic field.
Okay.
When you calculate the magnetic field inside will be uniform.
Yes. Okay.
It is like in an infinite solenoid.
Mhm.
If you have a uniformly charged sphere spinning at a constant angular velocity, the magnetic field will be uniform at all points inside the sphere, and at outside it will be a dipole field. But here we are interested only inside the sphere. What will be given by Lorentz? QV cross B. What will be the magnetic field in this case? If you calculate classical electrodynamics, I show only the result here. It will be proportional to the angular rotation of the shell, to the charge of the shell, and inversely proportional to the radius of the shell. If we compare this term with this last one here, they are the same. Because we have 2/12, which is like 1/6. Or we can put this like that. But this term is not present in Lorentz. It was what we discussed before, Mikhailov experiment. And this term is also not present here. It is like a centrifugal electrical force. But this term is equal in both theories. And amazingly, to those of you who are used to classical mechanics, what are these two terms here? These are the two terms which we find in classical mechanics when we are in a non-inertial frame of reference. This will be the centrifugal, and this will be the Coriolis term. Okay? But here they are applying two charges. It is the spinning spherical shell acting on an internal moving charge. So, if we make the experiment of Mikhailov, repeat it, the effect exists, then we can try to test if there will be or not the centrifugal term. It's also a different prediction. The Coriolis term will be the same, but the centrifugal is only present in Weber theory, not in Lorentz. And only to close here, if you apply a Weber's law to gravitation, and now you have a moving mass inside a spinning shell, massive shell, no charge involved, only a mass inside and a massive shell outside, spinning. What do you get? The same thing with M1, M2 instead of Q1, Q2. So what will you get? Essentially, MA, centrifugal and Coriolis force. This essentially is the essence of implementing Mach's principle with Weber's law. You begin with Weber's law, now apply to gravitation, and you show that, for instance, we say that the Earth is not inertial frame of reference. We need these two terms in the frame of the Earth. For instance, in Foucault pendulum, If we had only the tension and the gravitational force, they are in a plane. The pendulum should always move in a plane, but it does not. It precesses. If we are at the North Pole, it gives 1 turn per day. In principle, this has nothing to do with the stars. The stars could disappear in Newtonian mechanics, that the pendulum would continue to precess. Why? Because in Newtonian mechanics, a spherical shell does not exert force inside. According to Ernst Mach, this is wrong. It's not a coincidence that at the North Pole, the Foucault pendulum gives 1 turn per day, and the stars gives 1 turn per day, and they follow in the same direction. You apply Weber's law to gravitation, you show, mathematically at least, that you derive the Coriolis and centrifugal force as real gravitational forces due to the interaction between the test body, the pendulum in this case, and the distance universe, when in all frames in which the distance universe is spinning. They will create a real centrifugal and Coriolis force. I will not go into details here. This is the subject of another publication that we have. Those of you who have interest can see it later on. This here is the famous Newton's bucket experiment to show the existence of absolute space. According to Ernst Mach, this doesn't show this. It shows only relative rotation. So, in conclusion, Weber's electrodynamics predicts that a spherical shell of radius r, uniformly charged with total charge q, should exert a force on an internal accelerated charge, small q, given by this expression here. For a potential of 1.5 megavolts, an electron should double its effective inertial mass. No such interaction should exist according to Lorentz force. Modern experiments are trying to decide the question in the laboratory. These are all very recent experiments, the last 3 years. Also, the experiments about Ampere and Grassmann, they are for the last 20 years. But in this case, unfortunately, I believe it will not be possible to distinguish the two. But in this case, it's very clear the distinction. So now I think it should be interesting to discuss these things, and then we can go in more details if you wish. Thank you.
Eh bien, je vous en prie.
Well, one remark is this has to do with the discussion by De Broglie and Lucas. How should you distribute the mutual energy between interacting bodies? It is in close relation with what you have been discussing. And both De Broglie and Lucas have concluded that if one of the bodies is much heavier than the other, the whole mutual energy should be displaced upon the light body. And this is what will happen with the Weber force. This is one remark. Yes, okay.
This is only a first approximation to divide the mutual energy half and half.
Yes.
But if we have different weights, we can also distinguish this mutual energy separately. This is a possibility.
Yes.
And the other question is, should we apply E equals to mc squared to potential energy? In all the textbooks, they say no. And so, at least no to electrostatic potential energy.
Yes. Well, my second remark, well, first of all, I admire very much the work by Weber and the other people of that time. Nevertheless, I am a dedicated relativist. And I draw attention to the interaction electrodynamics of Wheeler and Feynman. There you have action and reaction, but the formulation is very much more sophisticated. I cannot go into details because I cannot expound the Wheeler-Feynman theory.
He works with advanced and retarded potentials and so on.
Yes, yes, and you have action-reaction, but the enunciation is very much more sophisticated than it is when you have absolute time and direct action-reaction.
Yes.
And in fact, it would be very difficult to transcribe the Weber theory in relativistic terms. But there is another theory of that time, which it is quite easy. It is the Clausius one. In fact, the Clausius-Lagrangian is the approximation to the Wheeler-Feynman Lagrangian. You have mutual energy going to mutual action. That's the way. That's all.
Yes,
So I think anyhow, these are very interesting open questions, and the discussion must be going on. That's no
Yes.
question about that.
And for this reason, I think it was excellent that the Annales de la Fondation Louis de Broglie published these two experimental papers by Mikhailov, because now the discussion did open worldwide. And I know that there is these people trying, which I did quote Levitt. I know another person with whom I already published some papers, and I will show here. This person here. We did publish a paper in Physics Letters saying 2000 about this centrifugal electrical force, predicting the effect. And this person here in particular, Fukai, is a Japanese, but he works for many years, has been working for many years at the University of Alabama in plasma physics. And he's also trying some experiments with Van der Graafs and so on, in the same line of Mikhailov and so on. The problem is that he's working with much higher potentials of the order of million volts. The effect should be much greater. But the problem is also that there are many more instabilities. You have discharge coronas and so on, and this disturbs enormously what you are trying to measure. But the importance, I think, is that after this publication, and these are two experiments, and they are clear, and I thought also extremely interesting that you did publish the discussion with the referees that did clarify enormously the first paper by Mikhailov, and that did help many people to try to understand and try to replicate these experiments. About the second one, with the Barkhouse generator, I'm trying up to now without success to convince someone in Germany to repeat these, because this generator was originated in Germany and there are still some of these generators working there, and so maybe they will try to replicate it with and without connections and so on and so on and so on. But I only want to let extremely clear, I myself am a Weberian. And I am pro-Weber, I am pro-Ampere's force between current elements and so on. They, with my own intuition, physical intuition, they are extremely compatible with that. I don't think they are the final theories, but they are the ones with which I work because I believe in them. I see much agreement with what they did present and with what we can get. And to me, the most amazing thing is this last aspect, which I only mentioned extremely briefly here, that we can implement the ideas of Ernst Mach with Weber's law for gravitation. For instance, in this case, this is the famous experiment presented by Newton in the beginning of the Principia to prove the existence of absolute space, a concept which Newton did present. According to Newton, when we have a bucket with water, it is at rest relative to the earth. The water is flat. Then Newton did turn the bucket and release the bucket. At the beginning, only the bucket did turn, but there are friction between the bucket, the walls of the bucket and the water begins to rotate. At one point, both of them will rotate together. That's the point which is represented here. And the water surface is concave. If we make the calculations with classical mechanics, it will be parabolic, but it doesn't matter. So the question which Newton did ask was the following. What is the reason that the water is flat here and concave here? Well, we could say it's very simple, because here the water is at rest and here it is spinning. But then Newton did ask, spinning relative to what? Distinction. And his answer was no. Why not? Let us read the three main suspects. Is the rotation of the water relative to the bucket, which is in touch with the water? Newton said no, because here both are at rest, and here both rotate together. And so there is no relative motion of the water and the bucket head. So the first matter, which is in touch with the water, you can eliminate. So, but then we could say, oh, it's obvious, it is the earth, because here the water is at rest relative to the earth, and here the water is spinning relative to the earth. But in Newtonian mechanics, what is the force which the earth exerts on the water? Only the weight downwards. And when the water is spinning, only the weight downwards. The earth does not make any lateral force, centrifugal force, only the weight downwards. Then we could say, here the water is at rest, essentially, relative to the remainder of the universe. And here it is spinning relative to the remainder. But Newton proved this theorem, which I showed here, which we prove nowadays with Gauss' law, that when you have a central force law, 1 over r squared, each star exerts a force in one direction, but all of them together, 0, no matter where you are. And around the Earth, we can think that there are many spherical shells. So we can forget about the stars, because they make no force here. And when the water is spinning, again it is 0. So according to Newton, it's not the rotation of the water relative to the bucket. It's not rotation of the water relative to the earth. It's not the rotation of the water relative to the remainder of the matter. But it must be something, because here it's flat and here it's concave. And so Newton said, this very simple experiment proves that there is, in this case, the water is rotating relative to something else, which has no connection to matter, which he named absolute space, which is vacuum, because there is no connection to matter. But then, 200 years later, Ernest Mach came and said, Newton is wrong. There are no meaning, matter moving relative to free space. There is only movement of matter relative to matter. In this case, the water must be concave, because this is spinning relative to the stars. If we could make the thought experiment, I have here a bucket of water. I let it here, at rest. If the Superman could go there and rotates all the stars and galaxies around the axis of the bucket, once in a second, it's a thought experiment, what will happen? No one knows. But in the theory, according to Newtonian theory, nothing. Because spherical shells do not make force inside, no matter if they are spinning or not. According to Mach, if the relative rotation is the same, the effect must be the same. So the water must go like that. So according to Mach, the centrifugal force is real, due to relative rotation with the distance universe. And if you apply Weber's law to gravitation, you show this force, at least mathematically, not experimentally, but you implement this idea that if you rotate the bucket, the water makes like that. If the bucket is at rest and you rotate the universe, the water will also be like that. So you can implement mathematically the ideas of Ernest Mach, which Einstein did try with his general theory, but at the end he himself convinced that this was not the case.
Yes, but other people have even thought about that.
Many people,
yes,
since
many, Sciama, for example.
Sciama has a force law similar to that of Lorentz, but for gravitation. And then he could try to implement the ideas of Ernest Mach. The problem with the Sciama force law, Sciama was published this paper in 1953, was that Sciama utilized mg, analogous to QE, plus mv cross gravitational magnetic field, BG. But the problem is that the meaning of this velocity. In Sciama, it is like in Lorentz, velocity of the mass relative to the observer, not matter relative to matter.
Yes, I agree.
And so this is, so he could not implement Mach's principle in all frames of reference. But
Woodward also have good thoughts that
about that as well. He not only made thoughts, but also published experiments about that. Woodward is working in USA and doing a different, completely different theory. It has nothing to do with this, but his also analogies between electrodynamics and gravitation. So there are different models trying to work in this direction. Weber model is one of them, and then you get exactly the equivalent results because you begin only with relational quantities. This is the most important thing. There are nothing here relative to the observer, only relative distance between the interacting bodies, relative velocities between the interacting bodies, relative accelerations. Who is measuring us doesn't matter. And to me, this is the most characteristic and the most important aspect of Weber's law. To me, it's not the final. Maybe there will be extra terms here, depending on R dot to the force power or to so on and so on. But
yeah, at this point I have a comment. If you have say 3 particles, you have always, or even for 2 particles, you have always, but it's better with 3, you have always a problem of reduced mass.
yes.
So how this problem of reduced mass is mixed with this problem of Weber correction mass? Does it goes?
Yes, goes together.
It goes together.
Goes
There
together.
is no an
And-
effect in a
and
sense,
it's
an
very-
effect is other. Or
there will always be action and reaction,
Yeah.
but they both go together. And this is a very, Professor Costa mentioned in the beginning, that in Weber's electrodynamics it was the first time that it did originate the expression E equals mc squared,
Yes,
because
that's very important,
extremely important.
We were the first to show equivalence of mass and energy.
Yes, many years before
Yes, yes.
because the modern ones is at the end of 19th century, at the beginning
yes,
of
but
20th
what,
century.
what I ask is the mass which counts the reduced mass or the real mass?
For 2 bodies,
Yes, for 2
Yes.
bodies.
yes. What you are answering, for example, is the problem of the hydrogen atom.
Yes.
Yes, okay. And yes, at lunch we
Yes.
discussed this matter.
And if you go to deuterium atoms, the correction should not be really the same. Or if you use this for a charge, as the charge are the same, there is no problem of relative charge, and there is also this problem of relative charge is there is no kind of center of mass or center of charge constriction, because if you have a neutral system, everything goes to 0 and it's a problem. But when you go to extension to Mach's principle, you have this, or you keep this center of mass constriction, and you have also to make it to cope with Mach's constriction. So
Yes.
did you try it, or to make it work and say it?
Something, and in principle it seems to work, but it needs to go in more details to see, especially with many bodies.
Yes, but you have not done it. Just to know, it's just a question of
The conservation of linear, angular, everything comes automatically. There is no problems about that.
Okay.
What we did discuss at lunch was 2 works. One was by Van Never-Bush in 1929, and recently by Paul Wesley, 1990 or so, that they did apply Weber's potential energy in Schrödinger's equation.
Yes.
And so you have the Coulombian contribution, which will be the normal energy levels, and with Weber's potential you have a perturbation in the potential, and when you solves this iteratively, this contribution, it gives the fine structure constant. This will give the usual energy levels, and this gives the... This was shown by...
Sommerfeld law for the energy levels.
Yes. But to me it's very interesting as well is this aspect of Ampere and Grassmann, because many people nowadays they are working the distinction of these 2 laws here. This 1820, 1826 is 1845. There are almost 150 years old, 170 years old, that people are discussing these 2 laws, and until today I would say that there are people convinced that this is the correct one, experimentally, theoretically. There are people convinced that this is the correct one, theoretically, experimentally. It's not yet a completely solved question.
Yeah. And in that case, if you go to intrinsic magnetism, say for spin, How does that cope with Ampere's law or Grassmann law?
Whenever you have spin, you have closed circuits. Then
Without closed circuits.
Then this is the question.
Because it's for a charge. You could have also
Yes.
some addiction to the force for the magnetic, for the truly magnetic.
Like here, I can charge, then I have a charge here, and then I can move it.
Yeah, okay.
Then in Maxwell electrodynamics, we will say, well, there is the displacement current that somehow closed the circuit. But will this displacement current contribute to tension here? If so, how much? No one has calculated that I know. And so, to me, open mechanical circuits are still open questions. To me, the closed mechanical circuits, not anymore. But there are people who still are convinced that this is the correct, not this. And the opposite, that this is the correct and not this. And there are people doing numerical integrations, analytical integrations, experiments with static current, experiments with discharging capacitor banks, measuring the tension in the circuit and so on. One experiment which they did do it, is what I did tell you, was this one here. It's very incredible experiment. You have here a capacitor bank, and here you have a switch, and here you have 1 meter wire, copper wire, very simple. And here you let a gap 1 centimeter air, very simple. And you suspend this wire in the ceiling, and you close the circuit like here. And you have a capacitor bank in the switch. When you close the switch, you create air gaps here, and the current flows. It's not a constant current, not at all. It goes and then oscillates. The current will be something like that, an exponential decay. It's not a constant at all. And when you have that, this wire here breaks, it explodes in many pieces. And normally they utilize, for instance, a wire of 1 millimeter, copper wire, 1 millimeter diameter. And this experiment is known for maybe more than 2 centuries, because when you have strikes in the atmosphere and so on, and fuses at home, everything is like that. But people thought that it did breaks because of the joule, because you heat the wire. But then, for instance, this Peter Granoux, working at MIT, he could analyze the fragments, and he did show that the fragments break at solid state. There are some points where there are arcs where they melt, but the break is in solid state, not due to, because it's too fast, microseconds until it breaks. It breaks, and it stops to break when the length is more or less the same order of magnitude of the diameter. You know that the tension to break the wire is proportional to the square of the current. You measure that. And what's fascinating, with Grassmann there is no force here, not at all. Longitude no one in this case, because it is straight. Not at all, no possibilities. When you calculate with Ampere, I did myself these calculations, you get a force, only these two here. The force of tension is proportional to the square of the current, as you measure. The force is proportional to the logarithm of the diameter, and it goes to 0, it explodes. And you measure and you observe that the force behaves like that. The force, you can vary the position here, where you separate part 1 and 2, and you show that